Okay, let's work on some polynomial applications. So here's our first one. It says, an open box is to be made from a square piece of material that's 36 centimeters on a side by cutting equal squares the sides of length x from the corners and turning up the sides. So we want to do a few things. We want to find an equation for the volume of the box. And just as a reminder to ourselves, we know volume is length times width times height. We want to determine the domain of the volume function. Now, we know that this is going to be a polynomial, which the domain for all polynomials is all reals. But because we are putting this into an application, we do need to restrict the domain. For example, this isn't really relevant to this, but like if it was a problem about height, like we wouldn't want to have negative height, right? So we want to restrict the domain based on, the actual context of the problem. And then last but not least, we want to find the value of x that will provide the maximum volume. And we want to find out what is that volume. And just a hint for this third part, you probably want to use your calculator. So I'll kind of get us started by drawing a picture, and then we'll see if you guys can do the rest. So I'm going to start by drawing a box. So remember we said we are going to make this open box from a square piece, and it says that it's 36 centimeters on a side. So this side is 36 centimeters. This side is 36 centimeters. And it said that we're going to cut these squares out of each corner that are x by x units. There we go. Okay, so all of these are x, each square. So again, just imagine that we would like cut out this square in the corner, and then we would fold it up. And then we would have our nice box with the open top. Okay, so what I'd like you guys to do is try to find an equation for the volume of this box. I'd like you to state the domain, and then maybe you can even go ahead and find the value of x that provides the maximum volume. So calculator needed here. Okay, so go ahead, put me on pause. Let's see what you can do. Okay, so I started by finding the function for volume. So we have volume, remember we said was length times width times height. We have to imagine this box as being, having a length and a width and a height. So key thing here is to identify that we need to know this, which would be the same as this. And that's going to be, it was a whole length of 36 before, but we have to subtract the 2x values here. So that's where that 36 minus 2x comes from. So length times width times height, or we could simplify it a little bit more. Next, I found the domain. Okay, so I said that the domain was 0 to 18. So, and that's not including 0 and not including 18. And we want to make sure that we understand what this means, right? We wouldn't be able to plug in values that are greater than 18 or less than 0. And if you don't really understand why, then plug them into your volume function. Let's see why that doesn't make any sense. And if you're unsure of how we got this, then let's chat. And then finally, to actually answer the third question, what's the value of x that will provide the maximum volume? I did need to use the calculator. So I did that. I plugged in my volume function. I looked for my max, and I did adjust my window using both my domain and just kind of guess and check as far as the y values went. And I found that x equals 6 centimeters would provide a maximum volume of 3,456 centimeters cubed. Let's try one more. Okay, it says a company that produces portable cassette players estimates that the profit for selling a particular model is below, where P is the profit in dollars and X is the advertising expense. We want to use this model that's given to find when the profit will reach $2,500,000. Notice that it did give us our domain already, which is really nice. So I'd like you guys to do this. I'd like you to find when the profit will reach $2,500,000. So go ahead and put me on pause and we'll see how you did. Okay, so we want to start by setting the profit equal to this $2,500,000, which I did here. Then I set the side equal to 0 by subtracting that number. And from there, I plugged that into my calculator. I was looking for x-intercepts, and I did find x about 38.436 would give me would be an x-intercept. Now, if you did this correctly and you plot this into your calculator, you would have noticed that there were two x-intercepts. However, we're trying to spend the least amount of advertising expense, right? That just makes sense. I could spend potentially two and I could get the same profit, but of course we want to spend the least amount. So that's why I chose that smaller x value. So to answer this question in a word form, since it is a word problem, it says to reach a profit of $2,500,000, the least amount of advertising expense should be $38,436. And again, that comes in tens of thousands of dollars.